Howdy doodly, studentinos. We're looking at example 8 here, and we've got we're doing expansions, and then we're finding something to do with the product of an expansion. So I've got two different binomials. One has been expanded, and you've got them timesing in each other. But first of all, we're going to do this first one, 2 take 3x to the 7. And it says to only do it as far as the term in x squared. I'm just going to write my coefficients in, yeah? So it's to the 7, so 1, 7, 21, 35, 35, 21, 7, 1. Now these 2's are fairly easy, 2 to the 7, 2 to the 6, 2 to the 5, 2 to the 4, 2 to the 3. 2 to the 3. I'll continue the rest if I need to, because I'm only going as far as to term in x squared. The one that's going to have an x squared term, come on, I want blue, is this minus 3x. So don't forget it's not going to happen in the first one, times minus 3x times minus 3x squared times minus 3x cubed. I didn't need to go this far because my minus 3x squared has already popped up. So I've got 1 times 2 to the 7 is 128, plus 7 times 64 times negative 3x, plus 21 times 32 times 9x squared. Don't need to go any further. They only I should probably expand this. So that gives me 128 plus 7 times 64 times negative 3. Wish I had my calculator. 7 times 64 times negative 3. So that gives me negative 1,344x plus 21 times 32 times 9 gives me 6,048 x squared. So it says to hence find the term in x squared in the expansion of that thing. So now I've got 5 plus x times 2 take 3x to the 7. All I'm going to bother writing of this 2 take 3x to the 7, actually that's in orange, is this line. There's a reason they got me to stop there. It could have kept going. So that's going to be 5 plus x times whatever we've got going here. 128 take 1344x plus 6048x squared plus whatever. So, you know the drill. That times that, that times that, that times that. We're only after the term in x squared though, so you may be able to think of a quicker way to do this already than what I'm going to do. So we get 5 times 128 plus 5 times negative 1344x plus 5 times 6048x squared plus x times 128 plus x times negative 1344x plus x times 6048x squared. So let's pick out the terms that have x squared, that are going to have x squared. So this one definitely will. And this one will also, because it's x times that x. So what we've got is 5 times 648x squared plus x times negative 1,344x. 5 times 6,048 is 3,240 x squared. Take 1,344 x squared gives me 28,896 x squared. So that's the term in x squared. in that expansion. Okay, there are some more difficult questions later on. So I'd like to have a look at one of the things from question 8 right now. Why don't I do 8b? Come on, crop. So we're just going to do 8b now. So we've got 2 plus root 7 to the 4 and 2 take root 7 to the 4. So 2 plus root 7 to the 4 is 1, 4, 6, 4, 1 times 2 to the 4 times 2 to the 3 times 2 to the 2 times 2 to the 1 times root 7 to the 1 times root 7 squared times root 7 to the 3 times root 7 to the 4 plus between each term. And then if I have to take root 7 all squared, then that's pretty much the same here. But every time I had an odd power of 7, I subtract that term instead. Because that would have been, for example, if I had root 7, negative root 7, then that's just minus root 7, so the minus goes out the front. If I had negative root 7 cubed, that's the negative of root 7 cubed, so the minus goes out the front. But if you've got squares, negative times positive, negative equals positive. So this time, if I'm adding them together, I'm going to add vertically. Oh, sorry. I want a straight line. So I'm adding vertically. So if I've got 2 plus root 7 to the 4 plus 2 take root 7 to the 4, then that's, I'll choose a different colour. 1 times root 2 plus 1 times root 4, which gives me 2 times, I said that completely wrong. 1 times 2 to the 4 plus 1 times 2 to the 4 is, 2 to the 4 plus 2 to the 4, which is 2 lots of 2 to the 4. Now, if I do this in a different colour, what happens here as I plus them? Because they're the same, so what's 4 times 2 to the 3 times root 7 plus negative 4 times 2 to the 3 times root 7? They cancel out. Okay. I've got 6 times 2 to the 2 times root 7 squared plus 6 times 2 to the 2 times root 7. So I've got 2 lots of 6 times 2 to the 2 times root 7 squared. For my next one, actually I'll do that in darker. Oh, sorry, went too far. I'm trying to colour these in a rainbow because I'm sick and rainbows make me happy. So I'm plussing these. Now you'll notice we've got the same thing, but we're, adding and subtracting, so it cancels out. And now finally, in green, these ones, you see, we've got 2 lots of root 7 to the 4. Now, 2 times 2 to the 4 is just 32. Plus 2 times 6 times 2 squared times, okay, so this is 2 times 6 times 4 times root 7 squared, 7. And then plus, and I've got 2 times root 7 to the 4 is the same as 7 squared. Because that's the same as root 7 times root 7 times root 7 times root 7, which does just give me, so here I've got 32 plus, oh gosh, this is huge, 2 times 4 times 6 times 7, yes I didn't do it in the right order, it doesn't matter, 336 plus, and then I've got 2 times root 7 times 7 is 7, times root 7 times 7 is 7. So I've got 32 plus 336 plus 2 times 49, whatever that was, 466. Therefore, it's rational. Because everything with an odd root cancelled out. I shouldn't have put an exclamation mark there after our last chapter. You'd be like, what's t factorial? Okay,